So far, what we have learned in our simple linear regression analysis are the following. Scatter plot, so that we would have an initial visual representation of our data. Then we would have our regression line, or the least squares regression line, or the trend line, so that we can visually see the model that we are building. And then we have our regression equation, which is the actual model that we are building. This equation is the actual model that we are able to build, so that we will be able to analyze and even predict future values based on the sample values that we would have. But these more refer to the nature of the relationship. Now that we know what the relationship is, we shall now look more into the following. The strength of the relationship, which can be described by the correlation coefficient, or R, and the coefficient of determination, or R squared, and then the significance of the relationship, that is by hypothesis testing in regression. We might know what is the relationship, we might know its strength, but is it significant? So these are the other things that we need to do in our simple linear regression analysis. So we have here some scatter plots. What we had in the previous example are just few data points. That's why it's kind of easy to see. But if we have a lot of data points, as you can see, we have here some correlation, then R equals something. Let's take a look at each. So here at the first one, as you can see, it says here correlation R equals 0. And if you're going to look at it, the points are somewhat really scattered. We can't see which direction the regression line can take. Here, it's close to 0.3. However, we can see that there's a general trend that it's going down from left to right here. Here, halfway between 0 and 1, it's as if we can see that the trend is going up from left to right, and the points are somewhat closer to each other. Here, the correlation R is negative 0.7, and as you can see, there are the data points are closer to each other and going downward from left to right. Here, very close to 1, 0.9, the data points are very close to each other and are going up from left to right. Similarly, very, very close to 1, almost 1, very close data points and going down from left to right. And all of these are actually described numerically by our correlation coefficient, R. The correlation coefficient determines the strength and direction of the linear relationship between two variables. So as you can see, we have here the values from 0 all the way to 1. And this is whether the relationship is positive or negative. So first, these are talking about the strength of the relationship. So as you can see, the range of values here, let's say for example, our correlation coefficient, by the way, is usually symbolized by R. This is also known as Pearson R, correlation coefficient. So if our R value is, let's say, 0.10, then we will say that it's a negligible correlation, meaning the relationship is not strong at all. It's something that we can actually neglect and ignore. But if our R is, let's say, 0.8, 0.80, we have a very high correlation. And this table will be our guide to see how strong the relationship of our variables would be. And that is strength. Now let's talk about direction. For direction, this is only whether it is positive or negative. if the direction is positive, meaning our R is, let's say, positive 0.7, that means as x goes up or as x increases, y increases. So as the independent variable gets more value, the dependent variable gets more value as well. However, if we would have a negative correlation, let's say r is equal to negative 0.9, that means as x actually increases, y is actually decreasing. And so, in terms of our graphs, let's just go back to the graphs that we had a while ago. Here, as you can see, if the given Pearson R's are negative, it's actually going down from left to right. But if the givens are positive, like this one, here and here, then it's going upward from left to right, like that one. And here are the ones going down. However, if the correlation is zero, there is actually no strength in the relationship. As you can see, the points are actually scattered because there is no strength in the relationship that we have. So again, to summarize, the strength of our relationship is defined by the value of our Pearson R, while the direction depends whether the given Pearson R is positive or negative. So, how do we compute for our Pearson R in Excel? So now here we are in Excel, and to compute for the Pearson R value, we go to Data, Data Analysis. There you go. Let's just take a closer look at that. And you can see correlation. So we select correlation, then click OK. Here, very simple. We just need to select the input range. So let's do that. Our input range is this two here. There we go. Then as we know, they are grouped by columns. The labels are in the first row and the output range. Let us just select it here down below. So when everything's okay, we click OK. And there we go. Let's take a closer look. So as you can see here, obviously, the R relationship between the variable and itself is perfect because that's just one variable. So we will take a look here at this specific value. As you can see, it is positive. And to look back at our scatter plot and regression line, here, as you can see, the data points and the trend line is actually going up from left to right. So it is just right that our R value is indeed positive. And it says here that our R value, if we round it off to 2 decimal places, is 0.95. And if we go back to our table a while ago, we can note that if our R is equal to 0.95, it has a very high and positive, very high and positive correlation. So the strength of our relationship between the dexterity and productivity is described by R equals 0.95, which means it's very high and it's a positive correlation.